different trig functions in them. So, I don't know. Let's see how we can handle this. First of all, let's try and see if we can consolidate some things. In number 3, I do see that I have a tangent and another tangent. Just tangent. I do have a cosine theta times tangent theta. I'm not talking about that one. I'm talking about the tangent of theta and the tangent of theta on the left side and on the right side. So if I try and consolidate those, then I'm going to try and move one of them by subtracting. Well, and when I do that, they're both positive on both sides, so they cancel. Okay, so that's one less thing that we have to consider. Okay, but we still have, we've got cosine of theta, and we have cosine theta times tangent of theta. So those are definitely two different terms. Think of that, if you need to, think of that kind of like a 3x and a negative square root 3xy. Okay, they're different trig functions, so they are different variables. Well, if this was the problem with the x's and the y's, if we were trying to handle that, it's a problem where we need to move everything to one side. We need to factor out what they have in common. They both have an x, they both have cosine of theta, so we're going to factor that out. Now, I don't know about you, but I prefer to deal with positive things, so I'm going to move the square root 3 cosine theta, tangent theta, just so that I don't have all these negatives to deal with. Okay, so it is gone from the right side. Everything is gone from the right side, so my right side is equal to 0. My left side, I have 3 cosine of theta plus the square root of 3 cosine theta tangent of theta. Okay, so with everything on one side now, I do see that these two terms both have a cosine of theta in them. So that's a GCF. I'm going to factor that out. I'm going to factor out the cosine of theta. So from my first term, when I take out the cosine of theta, I'm left with that coefficient of 3. From my second term, I'm left with the square root of 3 and the tangent. Any questions so far before I go any further? Everything that I've done so far makes sense. Okay, so go back to polynomials. When you factor and something's equal to 0, then we set each term of our factoring equal to 0 and we solve them individually. So we take the cosine of theta, set it equal to 0. We take that 3 plus the square root of 3 tangent of theta and set that equal to 0. Now, we've got a single trig function in this equation. We've got a single trig function in this equation. The problem has been taken care of. We can handle that. The cosine is equal to 0. That's where our x-coordinate is 0. So that is at pi over 2 and at 3 pi over 2. So there's two solutions. Okay, now this other one, we got to do a little work. We've got to get our tangent by itself. It was not isolated like the cosine was. So we begin by subtracting 3. Then we'll divide by the square root of 3. We don't leave square roots in the denominator, so we rationalize that. So that's going to be negative 3 square roots of 3 over 3, and the 3's cancel, so that's equal to the negative square root of 3. So that happens at pi over 3 in the second quadrant. So 2 pi over 3, and our pi over 3 angle in the fourth quadrant. So 5 pi over 3. So a lot of times with these, you're going to get 4 answers as well. You're going to get 2 answers from one part of the problem. You're going to get 2 answers from the other part of the problem. You can check these just like you can check any other one. Go back to the original, Now this one has stuff on both sides, so we've got to plug one of these values. I don't know, let's try 3 pi over 2. We've got to plug one of them into the left side, and then we need to compare that to the value we get when we plug it into the right side. Oh, okay. Glad I checked this, because when we plug in 3 pi over 2, tangent of 3 pi over 2, if you recall, is undefined, because that would be -1 over 0. We can't divide by 0, so even though we got it over here as a solution to the cosine of theta, in our original equation, it doesn't work. Okay? Pi over 2 would be the same thing. Okay? Pi over 2 would have the same thing, because it would be 1 over 0. So actually, both of those solutions get thrown out. Those are extraneous solutions. Remember, this is kind of like with rational equations. Remember back when we did rational equations, sometimes we worked it out, we got an answer, but when we plugged it back in, it doesn't work. We called it extraneous. That's what's happening here. It is an answer to part of our problem, but because of some other element, in this case tangent, in our problem, it gets thrown out. So you definitely want to make sure that you check these. Now, our 2 pi over 3 and 5 pi over 3 should be okay. Usually the only ones you're going to have to worry about are your pi over 2, your 3 pi over 2. Those should be the only two you have to worry about, because that's the only place tangent's undefined. Anywhere else, everything else is defined, unless, of course, you had a secant or a cosecant, but we're not going to deal with those. We're going to stick to sine, cosine, and tangent. Okay, so let me check one that does work. 3 cosine of 2 pi over 3 plus tangent of 2 pi over 3. Okay, so that's the left side of the equation. Let's check the right side of the equation. Negative square root of 3 cosine 2 pi over 3. Something you could do to save yourself a little bit of time and effort is to store 2 pi over 3 as x, so you don't have to type it in to every trig function here. It would save you a little time and effort. Okay, but moral of the story, left side of the equation equals negative 3.23, right side of the equation equals negative 3.23, so we're good. If 2 pi over 3 works, then 5 pi over 3 should be fine. Okay. Let's look at number 4. Number 4. Okay, number 4 is a little different. We don't have 2 different trig functions. However, we do have 2 variations of cosine. We have a linear cosine. It has a degree of 1. And then we have a quadratic cosine. We've got cosine squared. Same principle applies. This is a quadratic equation. It really is a quadratic equation in disguise. So quadratic equations, we always want those to be equal to 0. And I like my quadratic term to be positive, so I'm going to subtract the 2 cosine squared and subtract the square root of 3 cosine squared, even though that means that I have to move 2 things as opposed to 1 thing. I don't like dealing with a negative quadratic term. Oops, that's 0, not theta. Okay, so our left side in this case is equal to 0 because we moved everything from the left side. We've got 2 cosine squared of theta minus the square root of 3 cosine. That's not squared. Why did I put a square on that? That is not squared. That's just cosine theta. Okay, now if we're going to factor this one, what do they have in common? They both have cosine. Now, this does help some people. If you want to do this over to the side, you can replace that cosine with an x. If you can see that better, see the factoring that you plug out or that you pull out an x, and then you go back to the problem and you put the cosines back in the place of x. If you're struggling to see how it factors, okay, that's just a suggestion there.